Hello and welcome to Statecraft IAS Academy. I'm Atif, your geography educator. Today we are going to discuss about cyclones. But what is important about cyclones? When you take a look at this very article, you will see the relationship between sea surface temperature, global warming, climate change, as well as the cyclones. This is an article from Down to Earth, a very important journal as far as geography is concerned. If you're preparing for civil services or any other exams, you should always consider this journal because this contains very important things. From this very journal, today I got a very interesting article regarding the cyclones, where the marine heat waves supercharged tropical cyclones. This was an article. Now, the thing is that why are we so much concerned about marine heat waves? Because at the end of this class, I will show you a question directly picked from this. UPSC, from the mains perspective, I'm telling you, 2024, a question was taken from this, the rise in the temperature. That is why I today decided to explain you cyclones as well as the impact of sea surface temperature, heat waves. In a nutshell, let me tell you the climate change, global warming. All these things are responsible for the cyclone being dangerous, or we'll learn about that thing. Now, before going into that detail, first we need to know about cyclones. How they are initiated, how they are formed, why they are stronger at some places, why weaker at some places, and the factors responsible for their formation. Once we are able to understand the factors responsible for the formation of cyclones, then only we will be able to understand different factors like the temperature of the oceans that impact the cyclone. First things first, we need to learn about the cyclones. So, when we talk of cyclones, what are the cyclones? Every word written here is important. It is a rotating, that means it's not something that is linear, but a rotating, organized system of clouds. We have organized system of clouds. We will learn about that as well when we learn the cross section of the cyclones and thunderstorms that originate over tropical or subtropical waters and have closed level circulation. The most important thing that you need to understand here is they originate in tropical and subtropical waters. That is why when we divide the cyclones, we primarily divide the cyclones into two types: tropical cyclones and temperate cyclones. Right now we are concerned with tropical cyclones. Temperate cyclones, we will get a separate class on that, but today we are discussing the tropical cyclones. When we talk of tropical cyclones, these are found between the tropics mostly or in subtropical region. For example, this is the equator. The white line that you can see here is the equator. And if you draw a line around this region, this is the Tropic of Cancer. And similarly, 23.5 degrees south, you can draw one more line, and we call that as Tropic of Capricorn. So this is the region of tropics. And I told you, tropical cyclones are mostly associated with this region. The red areas here are the tropical cyclone areas where we mostly find the tropical cyclones. Occasionally, we can see the cyclones in subtropical regions as well. As is evident from this image, you can see we have slightly south of this line, slightly north of this line. Cyclones are present there. So usually it will be present around this region. Of course, you might wonder, sir, why are the cyclones present so far north here? I will tell you, but not now. Because if I start to explain you now, you might not be able to understand. After some time, when we learn various factors responsible for cyclones, then I will come back to this thing and explain you the reason for this extension towards north. Am I clear? So what did you understand? Cyclones are mostly found in tropical areas and slightly in subtropical areas as well. These are rotating, you know what rotating is, and they have closed low level circulation. First things first. Now, one more thing. When you look at this image, you might wonder, sir, we have hurricanes, we have cyclones, we have typhoons. Why so many names? These are the names of the cyclones at different regions. It's like naming the cyclones as per the region. For example, I might have named as Atif, but I might have some pet name, or somebody else might call me by some other name. Similarly, cyclones have different names in different regions of the world. For example, when we talk of Atlantic region or the region in the Pacific, Eastern Pacific, basically around the American continent, these are known as hurricanes. They are known as hurricanes. Where? In the Pacific and in the Atlantic around Mexico. They are known as hurricanes. Now, when we come to Indian Ocean, we know it's called cyclone. We are aware of the word cyclone only. So we know it's known as cyclone. Number 2. Number 3, very important. When we go to this China, South China Sea, East China Sea, these are known as typhoons. And when we go to the coast of Australia, these are known as wily-willies. So long story short, if I tell you like this, we start with the first thing, that is hurricanes in the American and Mexico region. Number 1. Number 2, we go to China region. They are known as typhoons. Number 3, these are known in Indian Ocean as cyclones. And when we go to Australian areas, these are known as wily-willies. So, long story short, whenever you hear these words, basically these are the synonyms. They mean cyclones only. Clear? Now, let's talk about the formation of cyclones. How are the cyclones formed? There are multiple factors that play their role in the formation of cyclones. First, warm ocean waters. They require the temperature of not less than 26 degrees. It can be high, it can go as high as 30, 35. That's not our concern. But it should not be less than 26. It should not be too cold. We have a minimum threshold. So, first thing we need is warm water. Now, I want to tell you before we go to the another factor. Why are these tropical cyclones located between the tropics and around subtropical regions? What are the reasons? Because the first condition that is responsible for tropical cyclone formation is warm water. Come back to this image. Tell me something. Do you think we will get warmer waters too much of north or south of the tropics? No, because tropics are the regions where we receive maximum insolation, where the temperature of water is ideal for cyclone formation. But as soon as we start to go towards poles, the temperature starts to fall. And the first condition required for formation of tropical cyclones is not met. Hence, we don't see cyclones in higher latitudes. Now, let me tell you about this cyclone in the Atlantic Ocean. If you are not aware of it, or let me tell you once we reach there, right now I'm going to explain you it quickly. We have the equatorial currents that carry the surface water. North Atlantic drift, Gulf Stream is present here, and then North Atlantic drift that takes warm water to higher latitudes. That is why, because of this very drift, we get warmer waters to mid latitudes and even a bit further. That is the primary reason we can see warmer waters present too much in the regions. That's why we have cyclone formation in the mid latitudes as well in this very region, because of the presence of Gulf Stream that carries warm water. It is a very important stream. We will learn about ocean currents when we reach there. If you're not aware, let me tell you, this is the coast of Canada. And at the same latitude, we have British or England coast. When you look at the temperature of Canada and England in the winters, you will be surprised to see that there is a huge difference in the temperatures between England and the coast of Canada. But why so? Because of this very North Atlantic drift. This North Atlantic drift plays a very important role in transporting warm waters to these regions. And when they transport the warm waters, they increase the temperatures. Okay, these warm waters will be taken from here like this, and this is where the England is located. So we will have warmer temperatures here comparatively as compared to this region. That is why you should know this Gulf Stream is very important, and that is why we have cyclones in the northern parts in this region as well. Okay, this is the first. Now, let's move ahead. So first condition, warm ocean surface water, at least 26 degrees. Should be more, but 26 is the minimum threshold. Number 2 is the Coriolis force. What is a Coriolis force? I have discussed this many times, that this is an imaginary force that deflects every moving object to right in the northern hemisphere and to the left in the southern hemisphere. If something is moving like this, it will be deflected like this in the north. If the same thing takes place in south, let's say something is moving like this, it will be deflected to left. This is Coriolis force. Why? Why Coriolis force is needed? Because it initiates the rotation. How does it initiate rotation? Just have some patience. I will explain to you how it initiates the cyclonic rotation. Right now, remember the points. Warm ocean water, Coriolis force. Low vertical wind shear. What's the wind shear? I will tell you with an example. For example, this is a surface. You will have a wind speed here, let's say 10 kilometers per hour. Okay. And if you go further up, you will have a wind speed of, let's say, 20 kilometers per hour. This is the wind shear. Okay, and this should be minimum. There should not be too much of a gap in the speed of wind at different levels. There should not be too much of a gap at different levels. You should understand this. We should have a low vertical wind shear. I will explain you each and everything, why every factor is responsible. Right now, all you need to do is have some patience and remember. Outflow of the upper atmosphere. This is also very important because it helps to drain out the winds in the cyclone once they go up. I will tell you this as well. And finally, atmospheric instability. Now, let us see how each and every factor that I have discussed here will play a very important role in formation of cyclone. Okay, let's start. I'm going to draw this for you so that you can manage it better. Let's say, first of all, we have warm waters that we require. So we are dropping of tropical waters in this region. Okay, here. This is the water that is present. And we have a temperature of 27 degrees. I'm expecting a temperature of 27 degrees because I told you, for the cyclone formation, we need a temperature of 27 degrees. So this warm water has already achieved the temperature of 27 degrees. Once it attains the specific heat, it attains the latent heat, it starts to evaporate. The water will start to evaporate. So it will start to go up. Okay, tell me something. Once the water starts to go up, not the water per se, but the water vapor, it starts to evaporate. A low pressure condition will start to develop here. A low pressure condition will start to develop here in this region. I mean, this much is very simple. I think we don't have to use too much of brain here. Because of this, the winds will be attracted from all the directions. I told you in the very first lecture, whenever we have a low pressure conditions, the winds start to blow from high pressure conditions. We have a comparatively low pressure system developing here. If you read the newspaper, you will read there a depression is developing in the Bay of Bengal. A low pressure conditions are developing in the Bay of Bengal. So I will explain you what that is right now. When low pressure conditions start to develop in this region, it will start to attract winds from all the directions. Okay. And the evaporation will continue because the temperature of water is already 27 degree. So it has achieved the latent heat. It has absorbed the latent heat and it will start to evaporate. Hence, the water will continue to go up. It will continue to go up. The water vapors are going up and the surrounding winds are coming to fill up the empty spaces. They are coming in and the water vapors are going up. Now, this is the role of temperature of water. One thing is clear. Why do we need warm temperature? So that we get the required evaporation. Now comes the role of what? Coriolis force. I told you, Coriolis force will start to move this in an anti-clockwise direction. Why anti-clockwise direction? Let me tell you this first. Let's come here. Listen to me. This is India. Okay. And a cyclonic condition has started to develop in Bay of Bengal. Let's say here. A low pressure condition is developing here. Am I clear? Ideally, it should attract winds from all the directions. Like this. Like this. Like this. And it will start to attract winds ideally like this. But I have told you, we are talking of northern hemisphere in the Bay of Bengal. This is India. Whenever we are talking of low pressure conditions, attracting of winds, but what are we supposed to do? We have to take Coriolis force into consideration. Once we start to understand what Coriolis force is, we know that it will start to deflect everything to right. So let's say this is the moment. Where will be the right? The right will be somewhat like this. Am I right? Similarly, the right will be somewhat like this. The right will be somewhat like this. And the right will be somewhat like this. Tell me something. Will this be the direction? And can you see it is somewhat moving like this now? Like this. Are you able to understand? Because of the deflection, the winds will start to move like this. Because of the deflection towards right. Are you getting my point? And tell me, you know about counterclockwise direction and clockwise. How does the clock move? It starts from 12, then goes 1, 2, 3, 4 and back 12. But don't you think it's going opposite to the clock? This is what we know as counterclockwise direction. That is why we have counterclockwise direction in northern hemisphere as far as the winds in the cyclone are concerned. Are you able to understand this? Why the winds are moving towards this low pressure? Because the water has started to evaporate already. So the winds will start to come towards this low pressure from high pressure conditions in all the directions. But we have to understand that we will see a deflection because of Coriolis force. Hence the blue arrows are showing the deflection. And these will lead to counterclockwise movement of the cyclone. This is the role of Coriolis force. Now come here. Listen, when we talk of this, the counterclockwise direction, how is it? Somewhat like this. Am I right? This is counterclockwise direction or not? Let me denote with the arrows as well. This is what we call as counterclockwise direction. Because ideally it should have gone up like this, but because of Coriolis force, it will start a counterclockwise direction. It will start to go round and round. And then we will have low wind shear. Vertical wind shear has to be low. Imagine the winds moving here with the speed of 50 kilometers per hour, and here we have winds moving at 10 kilometers. Don't you think this will disrupt this vertical movement of these? This part will start to move in this direction while this part will not be able to move. Why? Because here we have less wind speed and here we have high wind speed. So it might not allow this column to form. So that is why we require low vertical wind shear. Are you getting my point? This is the primary reason we require a low vertical wind shear. That is number 3. We are done. Now come to number 4, outflow in the upper atmosphere. Once the winds will go up and reach near to a certain height where we will witness maybe troposphere, or to some height where it will start to cool down, the winds have to move out. The winds will move out. If the winds are pumped out continuously, then the winds will continue to come up. Winds will not accumulate here. It will not accumulate, but the winds will be pumped out. And this will lead to formation of a condition called cyclone. Am I clear? Listen to me very carefully. Look at this image now that I'm going to show you. Take a proper look at it and tell me, are you able to understand this now or not? Because there is something you have to look. First of all, let me change the color. See, initially I told you that there will be evaporation. At 26 degrees, evaporation will start. Am I right? The winds from the surrounding areas will start to come in to take the place because a low pressure condition has already developed here. Clear? The low pressure conditions that have developed here will start to go in a spiral manner like this. Why? Because of Coriolis force. Water evaporates from the ocean surface and comes into contact with mass of cold air forming clouds. He's talking of upper atmosphere. Now, a column of low pressure develops at the center. Winds form around this column. You might get confused why a low pressure system is developing in the center. Let's get back to this image. Listen to me very carefully. Once the winds will start to go up in a spiral manner, they will go up like this. Correct? Like this. That is why we will have low pressure conditions here. And the winds will start to go along the wall. They will not rise in the center, but they are going up along this wall only. If you are able to see it, we are getting a spiral movement of air going up, but it is only along this very wall and not through the center. Hence, this area will witness a low pressure condition. A clear sky as well, because we are getting this area will witness clear conditions. If you take a look at this image, let me show you if I have one. Yes, exactly here. Look, we are getting the winds to move up along the wall. Clear? This is the wall. And in the center, there is no vertical movement. There are clear conditions, calm conditions. I've told you, whenever the winds will go up, only then there will be formation of clouds. But when you take a look at the central part, there are no winds that are going up. The only thing when the winds are going up are where? Along the wall, not in the eye. The winds are not going up in the eye, but they are going up along the wall of the cyclone. Are you getting my point? That is why we have calm conditions in this region. You will not witness any rainfall. You will not witness any kind of instability. At the same time, because the winds are going up along the wall, you will witness very heavy rainfall, formation of cumulonimbus clouds along the wall. The most intense rainfall that you witness in a cyclone is along the eye wall. Okay, if you look at the structure, let me explain to you the structure of a cyclone. We have eye wall, spiral rain bands, and upper level outflow. Eye wall and eye are very important because when we look at the eye, this is the region of calm. If somebody is standing in the eye wall, he will not witness any kind of instability. There is a very good possibility, if the eye is very mature, there is a very good possibility there will be good enough sunshine as well. The sunlight will be good. There will be no rainfall. But as soon as the person starts to go towards the eye wall, he will start to witness intense rainfall, thunderstorm, because of formation of cumulonimbus clouds. Spiral rain bands. There can be multiple rain bands. There cannot be only, this is the eye wall. There will be multiple eye bands. Now, let me tell you one more thing here. Let's say This is the eye wall. Don't consider my drawing because my drawing is very bad. Okay, if you look at this, this is the eye. Okay, this is the eye. For example, a cyclone comes, a person is standing here. This is hypothetical, it's not the way it is. I'm just going to make you understand how the things work. The person will first experience this eye wall. When he will experience this eye wall, he will witness very heavy rainfall. Once the eye wall will cross this person, the person will reach into the eye. He will be very happy. Okay, fine, the conditions are improving a bit. He'll be feeling okay, the conditions are good now, I don't need to worry about anything. But another eye wall will follow. Hence, this is how a cyclone is. This is how the cyclonic activity works. Are you getting my point? Eye wall, rainfall, eye, no rainfall. Then the winds go up, they start to be pumped out. As I told you, the winds are pumped out once they reach to the troposphere, and this is how the cyclone develops. Now, there is one more thing. How does the cyclone maintain itself and how does it dissipate? What are the factors responsible for the sustenance of cyclone and why does it dissipate eventually? How? Because we might be aware of the news, Odisha being hit by cyclones, Andhra Pradesh being hit by cyclones and other factors. But tell me something, how does the cyclone become stronger? Listen to me very carefully. Once a cyclone is located on a water body, this is a water body, okay? Let's say this is a water body, okay? This is a water body. So a cyclone is formed here. I'm going to form a spiral diagram here only so that we don't get confused too much. Now what happens is, it is continuously sucking air from all the directions because of the development of low pressure. And this air will be moist because the wind, it's present on a water body, a warm water body where we have a temperature of 26-27 degrees. So it is sucking these moist winds from all the directions. This leads to becoming the cyclone more intense because it is being continuously supplied with moisture. See, once it reaches here, once the winds start to go up, look, when the wind will go up, it will cool down. It will cool down, right? When it will cool down, it will release the heat it absorbed near the water body. Latent heat will be released. Latent heat concept is from physics. I hope you know about it. But latent heat will be released by the cyclone because now, because of the wind going up, it will cool. Hence, the latent heat will be released and it will lead to warming up of the surrounding region slightly, not too much, but slightly. Hence, the cyclone will start to further intensify. It will start to go up again and start sucking more air. Again, cooling of air, release of warm air, again going up. It will keep becoming stronger and stronger and stronger. Up until when? Up until it does not reach to a place where the water supply is absent. That means landfall. When a cyclone hits the land, the moisture supply is cut. It leads to dissipation of the cyclone. The cyclone ends. The life of the cyclone ends once the supply of the moisture is cut. If a cyclone is present on a water body for a very large amount of time, it will become very strong. The more the time it spends on a water body, it becomes more strong. Less the time it spends on a water body, it is not that much strong. So that is why as soon as a cyclone hits the land, the water supply is cut, the moisture supply is cut, because on land there is no moisture supply and the cyclone starts to dissipate. This is a reason, if you use the logic, we often witness the cyclones hitting the coastal regions of Odisha, hitting the coastal regions of Andhra Pradesh, Tamil Nadu, or any other place. It hits the coastal regions. Have you ever thought, if the cyclone comes to the coast, why doesn't it enter to the interiors of the region? Have you ever heard the cyclone entering the interior of Odisha? No, only the coastal area. Why? Have you ever thought of it? Why? Because the main reason is because of the fact once it reaches the land, the moisture supply is cut and the cyclone needs moisture supply. It keeps sucking moisture on water. But as soon as this moisture is not there, it doesn't get the moisture supply. So it starts to dissipate. And eventually, once it hits the cyclone, hits the coasts, it causes a lot of damage. But it dissipates eventually. Because of the absence of moisture supply. This is the main reason why we witness the cyclones along the coasts. You should question yourself, if you are not ever, that why are the cyclones present on the coasts only? What is the reason? Because it needs moisture supply. Am I clear? There is one more associated concept that you need to understand regarding the cyclones. What is that? That is the storm surge. What is a storm surge? Listen, this is associated with the tropical cyclone, so we need to cover it here only. When we talk of the storm surge, once a cyclone starts to approach the coast, a cyclone is coming. We have water, presence of water here, okay? And this is a coast. Because the cyclone is too powerful, there are gusty winds coming down from the cyclone. As I told you, we have gusty winds coming down from the cyclone. It raises the water slightly and pushes it towards land, and it reaches a temporary increase in the sea level. This is what we know as storm surge. Okay, this is temporary increase in the sea level. When the cyclone starts to approach a landmass, a coast, there's a slight increase in the sea level because of the frictional force that lifts the water slightly to a greater height. And this is what we know as cyclone surge, storm surge. And I told you about the dissipation of cyclone. Now we have one important thing. Did I tell you about the, I think I told you, yeah, structure we discussed. We have eye in the center, which has low pressure and clear weather conditions. Then we have eye wall, torrential rainfall, very heavy rainfall, maximum rainfall here, and it causes maximum destruction. Spiral rain bands are present there, multiple. See, if you look at these blue arrows, basically when the air is sucked up, then it's pumped out like this. It's pumped out. Okay, this is very important. Now, IMD uses a specific criteria to determine whether a cyclone, what's the intensity of cyclone. And this is something that you see in news every now and then. You might read the newspapers and not be able to understand. Sometimes you see that a low pressure area is developing, the depression is developing, the cyclone is developing. What is the difference? What exactly is the difference between all these terms? See, the difference is very simple. When we talk of classification of cyclonic disturbance as per IMD, the main criteria that is used for determining the difference is the sustained surface wind speed. Or let me tell you simply, what is the wind speed of the developing cyclone? When we have a low pressure area developing, it has a less wind speed of less than 70. How is that a low pressure condition? Can you correlate the things? Are you able to correlate the things or not? Listen to me very carefully. This is something I want to tell you. Listen. When we talk of low pressure areas being developed because of the evaporation of water, what did we witness? We witnessed a low pressure condition developing and the winds coming from all the directions, correct? So, it depends on this low pressure area. If we have a weak low pressure area, that will not attract winds with greater speed. I told you in the first class, if we have an area with a very less slope, the flow of water will be slow. The water will not flow that high. But if we have a greater slope, the speed of the water will be more, right? Similarly, it depends on the intensity of this. If the low pressure area is not that low, it will not start to attract winds that greatly. But once the intensity of the low pressure area increases significantly, the pressure difference will increase significantly. The pressure gradient force will become intensely strong and the speed of the winds will increase. And that is the exact criteria that IMD uses. First, it talks of low pressure area. A low pressure area develops less conditions, less wind speed because it's not that intense. But this is the condition, depression. This is a condition when the low pressure area becomes very strong. So it starts to attract winds with greater speeds. And this is when the IMD issues warning. If you go through your Google, you should check it. Depressions developing in Bay of Bengal, depressions developing in Arabian Sea. You go through it once. You will see all these things there. So IMD starts to issue warnings once the depression starts to develop. Then we have deep depression, even more strong. and then eventually the cyclonic storm. When the wind speed goes past 30 kilometers, 30 knots, sorry, my bad, 30 knots. When the wind speed goes beyond 30 knots, or we can say 62 kilometers, we witness a condition that is known as cyclone. Because at this time, there's a very strong low pressure in the center. The speed of the winds becomes very strong. Then there are other factors as well if the conditions continue. As I told you, the longer the cyclone remains on water, the more the intensity increases. The low pressure becomes more stronger. We can go to other categories like severe cyclone, very severe cyclone, extremely severe cyclone, and super cyclonic conditions. These are the conditions that develop if the cyclone is present on water for a very long period of time. Otherwise, we might not be able to see such conditions. There was a condition that struck Odisha. That was a super cyclone. Odisha was struck. After that, they developed the early warning system of the cyclones. That is a part of disaster management, but I'm just giving you an idea how the things work. Are you getting my point? Is there any confusion till now? Hopefully not. If there is, kindly let me know in the comments. Okay? Now I want to talk about the thing that I started with. That is the role of climate change or global warming on cyclone. Tell me something. This is a question paper. Hopefully it's visible. Yeah, it's visible. Okay, I was just checking, is it visible or not? Listen to me very carefully. This is a paper from 2024 mains, UPSC GS1. You can check it from internet if you don't trust me. I know you trust me, I'm just kidding. There's something wrong with my marker, I don't know why. GS1, okay, 2024. In this paper, you will witness a question, that's question number 4. What is sea surface temperature rise? How does it affect the formation of tropical cyclones? All you have to do is talk of sea surface temperature rise and then talk of its impact on tropical cyclones. Long story short, first thing is, what is sea surface temperature? First, you have to talk of sea surface temperature. What is the sea surface temperature? Sea surface temperature rise. Basically, it is the temperature of the uppermost layer of the sea. That is the sea surface. And when that temperature increases by 1.5 degrees, 2 degrees, that is the sea surface temperature rise. Of course, you will need to substantiate your answer with few examples. Talking of Indian Ocean. How in the past 20-25 years there has been 0.8 degree rise in the sea surface temperature. In such questions, you have to substantiate with the example. Okay, in the Atlantic Ocean, the rise in the temperature. In Pacific, it is not that, I mean, it's not that much, but in other regions, especially the Indian Ocean region, it has significantly increased. That is the rise in sea surface temperature, addressing the first part of the question. Now, the second part is what we want to talk of today, that we have discussed today. That is the article of the down to earth. Now, what is the role in the tropical cyclone formation? As I told you, when we discussed the role of sea surface temperature, I told you in the sea surface temperature, there is a very important role of in the cyclone formation, there is a very important role of sea surface temperature. Am I right? So, what happens is we need a minimum temperature of 26 degrees. Let me just put it down here. We need a temperature of 26 degrees. And at this temperature, I told you, we start to witness the evaporation of water. Correct? Now, let's say the temperature of the sea surface increases to 28 or 29. For example, this is too much of an increase, but let's say we have a temperature of 29. This evaporation will increase manifold. This will increase manifold because more temperature, more evaporation. Correct? So we will witness a huge rise of evaporation. Now, more the evaporation, more we will start to witness stronger cyclones. Because I told you, it will start to attract. No, see, listen. Here I told you that once a low pressure develops, it develops because of evaporation. right? But now the temperature is too high, so it will increase the low pressure conditions because there will be more evaporation, more air will be sucked in from surrounding areas. So the intensity of low pressure will increase many-fold. Number one, this is a very important factor. What will it lead to? An increase in the intensity of cyclones. If you want data, let's talk of data. A study published in Science Advances, this is a very important journal, April 10, 2026, found that tropical cyclones experiencing rapid intensification due to marine heat waves resulted in 60% more billion-dollar disasters compared to those without heat wave influence. What is a billion-dollar disaster? That causes disaster, that causes loss, damage of property, infrastructure, worth billions. It starts from 1 billion and goes onwards. That is minimum criteria is a billion. It's known as a billion disaster, billion-dollar disaster. Similarly, when we talk of these things, whenever, as per this report, this is not something I am saying, this is a report from the Science Advances, just a couple of months back, in which we witnessed that whenever a tropical cyclone passes over a marine heat wave, what will a marine heat wave do? It will lead to increase in the sea surface temperature. And once a tropical cyclone passes over the hot waters, its intensity increases too much, 60% more. That means if in normal conditions we witness only one disaster that causes $1 billion damage, because of the increase in sea surface temperature, we are witnessing 60. Ideally, if one, now we are witnessing 60. A 60% increase, that's a lot. Are you getting my point? Number one. A similar example can be quoted. It was in news for a lot of time, that Hurricane Milton. I told you about hurricanes. Hurricanes are cyclones, called as hurricanes in Americas and the Mexico region. Okay. In October 2024, when Hurricane Milton struck, it was so damaging, so devastating that it caused a damage of $60 billion. It caused a damage of $60 billion. And just a difference of 2 weeks, there was one more hurricane, Helen, which struck USA, Cuba, and Mexico. It also caused a damage of $55 billion and killed 232 people. Normally, when we see cyclones in Odisha, although India is a developing nation, we don't have that much of technology, but still we do not witness this much of a damage. At least up until now, we didn't witness, except for a few instances. Why? Because maybe the intensity of cyclones in this region is more. Atlantic is warming up more rapidly. More heat waves are witnessed in this region. Hence, the cyclones in these regions are very intense. Are you getting my point? How the intensity of cyclones increases because of more evaporation, more intensification of low pressure, and more strong cyclones. Intensity. Number one. So what should be the ideal answer? First, you talk of sea surface temperature, giving some examples. Number one. Number two, and very important thing that you need to talk of, is how does it affect the formation? This should be your introduction part, where you will explain what is the sea surface temperature rise, as I already told you. Then you talk of the formation of tropical cyclones and the role of rise in the sea surface temperature. Ideally, what you have to do is briefly tell about the factors responsible for formation of tropical cyclones. Not write the detail, just mention 3 points. That is warm ocean waters 26 degrees, number one. Second point has to be this Coriolis force, and number three, just in 3 lines. Don't start to explain, because the question demands the role of warm waters. So then you start to write about the intensity, how the intensification of cyclones takes place because of warm waters. Clear? That's number two. Then you have to write about the zones of cyclone. See, listen to me very carefully. I told you that the cyclones are mostly located in the tropical and subtropical regions. Correct? Why? Because we require a temperature of 26 degrees. Now, my question is, if we require a temperature of 26 degrees, ideally, we get this temperature in the tropics or slightly north and south of the tropics, that is, in the subtropical zone. But if the temperature of the sea surface increases, we're talking of sea surface temperature, Once it increases, what's going to happen? Ideally, we would get a temperature of 27 degree here, okay, 26 degree here, and we started to witness less temperatures in higher regions. Just give me a second. Let me clear this. Listen, now, when we talk of sea surface temperature, why did we witness the tropical cyclones only in these regions? Because when we talk of tropical cyclones, we get a temperature of, let's say, 27 here, 26 in this very region. But as soon as we go to the north, we start to witness less temperature, let's say 23. So this is the temperature where we cannot witness tropical cyclones. But as the sea surface temperature increases, instead of 27 degrees here, we will witness 29. This is an example. This is not the exact value, but you have to understand. You can use this example in your exam as well. Okay. So instead of 27, we will witness 29 degrees. Instead of 26, we might witness 28. And instead of 23, we might witness 26. Because it will lead to an overall increase in the temperature of the sea surface. It's not that it will be restricted to a specific region. Hence, ideally, when the cyclones were witnessed only in the tropical and subtropical regions, can now be witnessed even in the temperate regions as well. And this is a fact. We have started to witness cyclones in the higher, not the higher latitudes, but the mid latitudes. Ideally, that should not have been the case because they had cold waters, less than 26 degrees, 23, 22, 20. But ideally, where there should have been 20 degrees, now we are witnessing 25, 26 degrees. So we are witnessing cyclones in those regions as well. So this should be your second point. First point is the intensity and the frequency of cyclones. Second is the spread of cyclones. It is located in the regions not seen before. Explain both the points. And the third point that you need to explain is that these cyclones, the frequency of cyclones increases. If you are aware of the current affairs, you see now more cyclones come every year than ever because there is more availability of warm water, more evaporation, more formation of cyclones. So we have more cyclones as compared to previous years. 3 points that you need to explain in this question is: first, intensity, more areas in higher regions, and the third is the frequency. Am I clear about the sea surface temperature? Now, the last point of our today's lecture is the Coriolis force and its impact. I told you Coriolis force helps in the formation of cyclones. Tell me something, is there something unique that you are able to see? You do not see any cyclone. See, this is the region of cyclone, cyclone, cyclone. You do not see any cyclone on the equator, right? Hardly. Why no cyclones on the equator? It's present to the north of equator, to the south of equator, but on the equator there are no cyclones. What could be the possible reason? I told you that we have zero Coriolis force on equator. There is no Coriolis force on equator. And I told you we need Coriolis force for cyclones. And if there is no Coriolis force on equator, we have no cyclones on equator. No cyclones on equator. Cyclones never cross the equator because once they start to reach equator, they dissipate. There is no Coriolis force. This is how the things should be written. How Coriolis force is important. Let's say tomorrow a question comes on Coriolis force. It's not important that it will always be asked on sea surface temperature. They asked about the sea surface temperature. Now they want to know about your understanding of Coriolis force. So you need to draw the diagrams that I showed you already. Where are the diagrams? This one, this diagram, how the direction is changed and why we have no cyclones on the equator. One last thing that I would like to tell you is normally under normal circumstances and most of the cases what we witness is that there is a fixed direction in the Indian Ocean in which the cyclones move, although it changes slightly. But when we talk of the movement of cyclones, let's say a cyclone develops in Bay of Bengal here. It moves towards India. It hardly moves towards east. Why does it move towards India? What is the reason? What do you think? Two reasons primarily. We have land mass here, so we have low pressure conditions developing because of high heat. Cyclones develop during high temperatures, they don't develop in cold waters. That's one reason. And the second and the most important reason is when we talk of the regions, we have easterlies that are present here. Now, easterlies will push the cyclone towards east only, or towards west, towards India. This is the direction of the wind. A cyclone is forming here. Why will it get pushed towards India? That is why most of the cyclones are hit in these regions, in Odisha, in Andhra Pradesh, in Tamil Nadu. You will witness minimal, very least cyclones. You will hear very less news where a cyclone hit Kerala, where a cyclone has hit, let's say, Mumbai. Very less information about those things. It might hit Gujarat occasionally, but that's a different reason. I told you about the high temperature of the land masses. But ideally, there was a cyclone Asna that was supposed to hit Gujarat, but luckily it changed its direction. But now you can understand why mostly we are witnessing cyclones in Odisha, in Andhra Pradesh, in Tamil Nadu, and not on the other side, on the west coast. Because the cyclones that develop in Bay of Bengal get carried towards India by the easterly winds. You know about winds. This is Tropic of Cancer, this is Tropic of Capricorn. We have winds like these, right? Am I right? So that is why these winds drive these cyclones towards the east coast. So that's all from my side. This is very important. I told you why they are in the counterclockwise direction in the northern hemisphere. In the southern hemisphere, they will be in the clockwise direction. Now, I hope you know why they are in the clockwise direction and you are not confused about that. But still, I'll give you a brief idea. See, listen. In the southern hemisphere, a low pressure condition develops. It starts to attract winds like this and like this. Okay? Now, in the southern hemisphere, everything is turned towards left. Good. Due to Coriolis force. This is left. This is left. This is left. And this is left. Now, what is the direction? Don't you think it's somewhat like this? And that is how the clock moves. Like this. It starts from 12 and then moves like this. I didn't explain you this clearly because this is self-understood. Preparing for UPSC, I expect you guys to know this much. And I told you whatever happens in northern hemisphere, just reverse the direction and you will understand everything. And mostly we are concerned with northern hemisphere. Until and unless you are specifically asked about the southern hemisphere, you can assume things about northern hemisphere. So that should be all from today's class, and the motive of this article from Down to Earth, that is marine heat waves, supercharged tropical cyclones. If this is a question in your mains, what are you going to write? Because sea surface temperature, increase in the intensity, change in locations, more frequency of cyclones. That should be all from today's class. I hope you understood. If you have any confusions, you drop it in the comments and I will get back to you. Till then, bye-bye. See you next time. Bye.